Hey everyone, this is Derek, and this is 3.4 Equations of a Line. And so in the last video and section, we looked at slope-intercept form, but more from a graphing point of view. So this section will be a little bit more algebraic in terms of how we're approaching problems. So a couple of things we haven't seen yet, parallel and perpendicular lines. So lines that lie in the same plane but never intersect, those are called parallel lines. So basically if the slopes are the same, the lines are going to be parallel because they're just going to kind of follow each other off to infinity. Lines that intersect at right angles are called perpendicular. So for instance, you know, these two lines that are making up this box, that is a right angle or 90 degrees. Likewise down at this corner or the side of the paper, those would all be perpendicular. And when we're looking at the equations of lines, if we multiply the two slopes together, they make -1. That's always the sort of definition of perpendicular. An easier way to think of it is going to be the opposite of the reciprocal. And I think I will show that in the context of a problem. So here we're asked to determine whether or not the lines are parallel, perpendicular, or neither. So what I really need is to figure out what the slope is, because if the slopes are the same, then they're parallel. If the slopes multiply to -1, they're perpendicular, and if it doesn't do either of those things, then that'd be a neither. So I'm just going to take this equation, and probably the easiest way to figure out what the slope is just to get into y equals mx plus b. So I'm going to move my 2x over. That's going to leave me -3y on this side. I'm subtracting the 2x from both sides. And then let's divide out that -3 everywhere. And so that's going to leave us y equals double negative, so that's positive 2/3 x. And then -1, we don't care that much about the -1 because what we want is right there. So the slope on that one is 2/3. So then let's grab this next line and do the same thing. So I'll bring the x over, and I got 6y equals -9x because I'm subtracting. And then dividing everything by 6. So this will give us y equals -9/6. So that's the same thing as -3/2 x, and then -1. And again, we don't really care about the intercept. The important thing is these two slopes. So not the same value, so these are not parallel. So now if we do, does m1 times m2 equal -1? So 2/3 times -3/2 does indeed, right? Because it makes -6/6, and that is -1. So we would say these are perpendicular. So here's an easier way to think of perpendicular. If my first slope is 2/3, if I flip it over and reverse the sign, that's what's going to make it -1. So if this one's 2/3, the upcoming one would have to be flipped over 3/2 and negative. So right there. So say I'd solved and say I'd gotten, I don't know, 5/2 negative as my first slope. Then my second slope would have to be positive to counter the negative 2/5. If I'd solved and my first slope was 3, then my second slope would, for perpendicular to that, would be -1/3. I'm just taking that 3/1, flipping it, and changing the sign. So that's probably the easier way to think of perpendicular, but that's how it works with the definition. This next one is the same directions. So we'll just take this and write it a little bit bigger. Same thing here. Okay, so here I'm going to bring the x over. And then let's divide everything by -2. So here, double negative makes y. Double negative, think of a little invisible 1 right there. So I'm going to think of that as 1/2 x. You could also think of it as x/2. They're the same thing. This just feels more like a slope. And then double negative there, leave us a +1. Again, we don't care, but there it is. I'm bringing this 6y, I actually bring this 3x over. and then we'll divide everything by 6. So that leaves me y equals 3/6, same thing as 1/2, plus 1/2. So these ones we would say are parallel because they ended up with the same slope. Okay, so we did slopes for horizontal and vertical lines back in 3.2, and here we're getting the actual equations for them. So a horizontal line is always going to take the form y equals some value b, the y-intercept. And the reason for that, and let me just do it right here. So like y equals 3, for instance. So that's going to be a horizontal line through 3. And people really want y equals to go this way because that's the y-axis and it goes this way. But if you think this through, if we make a little table here, I'm not big on tables, but let's do it for this one. When x is 0, this says it really doesn't matter. Y is 3. And then how about if x is 1? Still doesn't care. Y continues to be 3. So you can say you can do that forever. When x is 0, y is 3. When x is 1, y is 3. When x is 2, y just keeps being 3. And that's going to get you a horizontal line. So when I was a student, I kind of would remember, they're backwards what I think. Y goes this way for the lines and x is going to go this way. But if you ever kind of psych yourself out, just look at the equation, think of what the table would look like, and that's what it's got to do. And this asks us to state the slope. So remember, for horizontal lines, if we think of this as a hiking trip, the slope on that is 0, right? This is flat, and so it's all run with no rise. Over here, we're sketching a graph of negative 2x equals negative 6. So we just need to get that in a little bit better form. So that is really x equals 3. So if I kind of do the same logic that I did over here, this says x is 3. What's y? Doesn't matter. X is 3. X is still 3. Y still doesn't matter. Maybe it's 3 this time. So when x is 3, y could be 0. When x is 3, y could be 3 or any other value you might think of. And so that's how we get our vertical line. So that's what x equals 3 looks like. And in this case, if we're hiking, you'd be like, that kind of seems like an infinite slope, which is true. It does not exist because we're trying to divide by 0. So the slope for this one is undefined, or on the computer, DNE. So horizontals are y equals, verticals are x equals. And horizontal and vertical lines are perpendicular to each other. So that gets us to this next little round questions. So they are all give the equation of the line described. So a vertical line, so verticals, remember, are x equals, that passes through this point. Well, that's the x coordinate, so I bet it's going to be negative 4. But let's do a quick little sketch over here, not a good one, just to kind of orientate our brain and see what we're doing. This is giving me this point, negative 1, 2, 3, 4, and up 1. And then it's saying it's a vertical line passing through that point. So vertical lines, again, x equals, and then hopefully that helps it to make sense. It's just the x coordinate of that point. Perpendicular to x equals 5 passing through 1, 3. So if it's perpendicular to x equals 5, it's got to be y equals, right? Because perpendicular to a vertical will be a horizontal, and that's a y. So again, we can kind of, once we get past that little bit of logic, we can go, well, it's going to be y equals 3. But let me do kind of, again, a quick sketch over here just to kind of help you see that. So this is x is 1 and y be 1, 2, 3. So we're going through that point. The line x equals 5, that would be out here somewhere. That would be x equals 5. And so the line that I'm looking for is perpendicular to this, going that way. So there's our y equals 3. And then parallel to the x-axis passing through that point. So when x is 3, y is negative 4. And this is going to go parallel to the x-axis. So if it's parallel to the x-axis, that is a horizontal line. So that's going to be our y equals negative 4, because we're passing through negative 4. So again, you don't need to draw these. This is just to kind of help you see, if it's vertical and through this point, it's the x. Perpendicular to something vertical had been horizontal, so it must be the y. Parallel to x, that's horizontal, so it must be the y. So that's the quick version. Okay, and then this section wraps up with actually finding the equation of a line. And so steps for that are, step 1, find the slope. And so sometimes it's right there, which is great. And then sometimes you're gonna have to work for it a little bit harder, but that's step 1. And then step 2 is you're gonna be given a point. Somewhere you have to be given a point in the problem to kind of nail down where the line's going through. And then what we do is with a point and a slope, we have this y equals mx plus b, right? So y equals mx plus b. We know m, it's negative 2/3 in this case. This is negative 6, 1. Let me just write a little bit bigger. That is an x and that is a y that satisfies this equation that I'm trying to write. So what that means is I know 3 of the 4 letters and now I can solve for b. And so that's what step 2 is essentially, is just substituting your slope and your point in for these 3 and solving for b. Once you have, and remember when we're solving for the equation of a line, there's 2 things we need, and those are m and b. So we'd have m, we got b, we're set. So for this one, we will put y is 1, m is negative 2/3, x is negative 6, and b is what I am trying to figure out. So 1 equals negative, negative be positive, and then this would be 12 over 3. I'll make that a 4 in just a second, but let me do that much for now. So then 1 equals 4 plus b, and then shooting that 4 over, that'd be negative 3 equals b. So then the actual answer, we still gotta write the equation. So y equals mx plus b, I need to write y equals, and then come back and grab my m, 2/3 x, and then plus that b, negative 3. So that'd be my equation. Okay, same thing, finding the equation of the line. And this is where I was saying sometimes you're gonna have to work for the slope a little bit more. So this time they just gave me 2 points. So we gotta go back to that, the slope formula, y2, y1, x2, x1, and then get our slope. And then we can use either of these points, it won't matter which one. And it basically becomes the last problem. And that's kind of what we're trying to do, is reduce all of these down to that last problem I just did. So to find m, we'll go y2 minus y1 over x2 minus x1. And careful with that minus, that negative. That's right where everyone messes that up. Make sure I didn't. Nope, did good in the notes. So let's see, negative 2 over 6. So that reduces to 1/3. And then it's not like either of these x's is going to play well with that 3, so it doesn't really matter which one I pick. I'm going to pick the one without negative signs as my point, so I'll let that be my xy. But if I did this, it would be the exact same thing. Well, I'd come up with the exact same value for b, I should say. So now we're going to do our y equals mx plus b. Y is 1, m is negative 1/3. And then x, careful not to jump over to that point, x is 4. So that's the same as, I think I'll come up here so I don't run out of room. Y equals negative 1/3 of 4 being negative 4/3 plus b. I'm going to add that 4/3 to both sides. That's going to get off of this side and put it over here at the 1. And then here, we want to get a common denominator, like we did back in the fraction review at the beginning of the course. So that will be 3 plus 4 would make 7/3. This will be 3/3 and 4/3 for 7/3 is our b. So that gives us y equals negative 1/3 x plus 7/3. Okay, question 8. Find the equation line perpendicular to this that contains that point. So there's our point, x, y, and this is really nice. They gave us the point 0, 5. So when x is 0, y is 5, that is my y-intercept. So that's my b. And so then I will take this, and if I solve this around for y, then I can see the slope. Once I know the slope of this one, that gets me the slope of the perpendicular line. So I'm going to bring my 2x over, leaving me negative y, careful not to lose that sign, equals negative 2x plus 5. And then I don't really want negative y, so we multiply everything by negative 1. And that gets me y equals 2x and then minus 5. So my slope here is 2. My slope perpendicular, that little upside down T is the sign for perpendicular, would be negative 1/2. So, pretty cool. Now I just have y equals negative 1/2 x plus 5, because remember that's my y-intercept. Number 9, find the equation of a line parallel to this graph. Okay, that's cool. That's y equals negative 3x plus 2. So m is negative 3. And then the way that we shorthand parallel is two little lines like that. So m parallel is also negative 3. And then contains the point negative 1, negative 1. There's my point. There's my xy. So I can just put that equation right into y equals mx plus b and solve away for b. So y is negative 1, m is negative 3, and x is negative 1. So negative 1 equals, that makes a positive 3 plus b, and then subtracting on both sides, I got negative 4 equals b. So my equation will be y equals negative 3x minus 4.